Here now we are coming with one more video on height and distance. We will give you just 5 typical problems, and once you understand these 5 problems, you will be able to crack any question on height and distance. Just 5 simple questions. And if you understand the concept behind these 5 questions, then you can solve any question on height and distance of class 9 or 10 level. So here we give just 5 sums and the concept behind them and the solution. Once you master these, you can solve any and every sum on this chapter. Now the following discussion applies to height and distance for middle school levels, that is to say up to grades 9 and 10 only. For all questions on height and distance of classes 9 and 10 level, you will not get anything beyond what we are saying. Now, the ability to solve the question, whatever may be the question, if it is from the height and distance chapter, you need just 2 skills. That is drawing the correct diagram and identifying the correct right angle triangles. All you need is these 2 skills: drawing the correct diagram and identifying the correct triangles. Now, in almost every question on height and distance, you will have a horizontal line representing the ground level. Always we will have the ground horizontal line. Sometimes there could be a line at a height. For instance, someone is seeing something from a hilltop or an aeroplane flying, but the ground level will always be there. One or more vertical lines forming the altitude. One or more vertical lines. This could be building, tower, pole, flagstaff, monument, anything which is vertical. And one point of observation. This is the point of observation. And when you join these, the top of the tower or pole or whatever it is, when you join the top of this vertical line with the point of observation, this is the hypotenuse, which is at x degree, that is the angle of elevation, and you get a right angle triangle. In some cases, you may have a horizontal line. For instance, an aeroplane is flying here. In that case, this would be the angle of depression for a person in the aeroplane. But then this angle is equal to the alternate angle. So again, you can get the right angle triangle. So let us see how we can solve the questions. Now, first of all, some typical diagrams. The first one is the simplest one. You got the horizontal ground. You got a point of observation. You have got a vertical height, pole. It can be pole, it could be building, it could be monument, it could be tower. One vertical height. Here we have written pole. And the person here is looking at the top of the pole, and this is the angle of elevation. One ground, one height, and the hypotenuse forming the line of sight and the line of observation, and this is the normal angle of sight, the ground, and this is, he has to raise the telescope to look at this side, and this is the angle of elevation. Now slightly advanced, we are having a pole. It is being observed from 2 different points, point 1 and point 2. And from each point you observe, you get 2 different angles of elevation. From the point 1, you are getting this angle of elevation. From point 2, you are getting this angle of elevation. But note that when you are observing from far away, the angle would be less. And when you go nearer the building, the angle would be greater. So this angle will always be less, and this angle would be always greater. So if this is x and this y would be always greater. Observing the building from nearer the base, the angle of elevation would be greater. Observing the building top from far away from the base, the angle of elevation would be smaller. Here we have the same thing, but we are observing it from two different points on opposite side. Here the two different points were on the same side. Here two different points on the opposite side, and we are getting two angles of elevation. Here we have two different heights, pole 1 and pole 2, and a point of observation somewhere here. When we look at the top of pole 1, angle of elevation is this, and when we look at the top of pole 2, then this is the angle of elevation. Now here we have two heights, one upon another. Supposing a hill, and on the top you have got a pole, and you're looking at the top of the hill, which is the same as bottom of the pole, and also you're looking at the top of the pole, getting a smaller angle when you look at a lower height and a greater angle when you look at a greater height. And here we have an aeroplane flying here, and the aeroplane, from the aeroplane there are 2 points of observation. The aeroplane is looking at point X, the aeroplane is looking at point Y, and this is the angles of depression when the aeroplane or a person from the aeroplane is looking at X. This is the angle of depression, and when the person from the aeroplane is looking at Y, then this is the angle of depression. But then, as we said, these are alternate angles. The angle which I'm marking, these are alternate angles, and hence will be equal to this angle of depression. This angle of elevation will be equal to this angle of depression. In each case, that means a person in the aeroplane looking at X and a person at X looking at the aeroplane, the angle of depression and the angle of elevation shall be equal. Now let's see how we apply. Sample problem 1. The height of a tree is √3 times the length of its shadow. Find the angle of elevation of the sun. So this is the tree and this is the horizontal ground. This is the sun somewhere here. The light of the sun is coming and this is the shadow. So this is the height of the tree, this is the shadow, and it says that the tree is √3 times the shadow. And we have got a right angle triangle with this one as the angle of elevation. Say supposing this theta. Now let's see. So we have the sun and the light coming here. This is the shadow and this is the tree. Now AB by BC, that is tree by shadow, is √3 given in the question. Tree is √3 times the shadow. So AB by BC is √3. That is tan theta is √3 provided this angle is theta. So this is vertical by horizontal. So tan theta will be √3. But √3 is the value for tan 60 degrees. √3 is the value for tan 60 degree. So tan theta equal to tan 60 or theta equal to 60. That means if you want to look at the sun, the angle of elevation should be 60 degree. So that's the answer. The angle of elevation of the sun is 60 degrees. Sample problem 2. On walking 50 meters towards a building, in a line through its base, the angle of elevation changes from 30 to 45. Find the height of the building. On walking 50 meters towards a building, the angle of elevation changes from 30 to 45. Find the height of the building. So we have a building here. First of all, we must have a horizontal ground, and on this we have a building. Now the person was standing here. This was the first point of observation. Then he walked 50 meters towards the building. That means the second point. There is the first point of observation and there is a second point of observation. And this distance is 50 meters because he walked 50 meters towards the building. From here, when he was looking at the building, it was 30 degrees. And from here, after walking 50 meters, when he was looking, it was 45 degrees. So this was 30 and this was 45. Again, you can check that when you are standing nearer the building, the angle is more. And when you are standing far away from the building, the angle is less. And this distance is 50 meters. Now we can see that AB is the building, height h meters. And this is 50 because he walked 50 meters. And this is x. So the total should be x plus 50. So height by x, we are taking only this triangle number 1, only this smaller triangle. H by x is tan 45, that is 1, so h equal to x. Now we are taking the full triangle. The base is 50 plus x. So h upon x plus 50 is tan 30, that is 1 by root 3. Now from this equation, h equal to x, we replace the x with h because h and x are equal. So we write h upon h plus 50, 1 by root 3. Then we simplify and get the height of the building as, that is AB, the height of AB as 68.25. Only note that whenever we are getting root 3 minus 1 or root 3 in the denominator, here we are getting root 3. You may get root 3 minus 1, you may get root 3, or you may get root 3 plus 1. But in this case, we are getting root 3 minus 1. We always rationalize the denominator. That is one thing. And secondly, the value of root 3 is 1.73 or 1.732. And we are getting the height of the building at 68.25 meters. You can pause the video and look at the calculation. Sample problem 2. The angle of elevation of the top of an unfinished tower from a point 80 meters away from the base was 30 degrees on Monday. On Friday, the angle of elevation became 60 degrees. Find the height of the tower that was built between these 2 days, during this intermediate period. This was a building, but the building was finished later. At first, it was only till this much. Later, it was completed till this. And this is the horizontal ground, and the point of observation is constant. And this distance is 80 meters. All the observations are being made from 80 meters. When the building was unfinished, the angle was 30. And when the building was finished, the angle was 60. The angle now is 60. So the base is constant, 80. The height is different. This is height 1 when it was unfinished. This height 2. You have to find this height, the extra height that was built. So BC is the unfinished or incomplete tower, and AB or AC is rather the completed tower. So AB was the extra height built, and X is the point of observation. Join these two. First, we take the smaller triangle BC by 80. The horizontal distance is 80, equal to tan 31 by root 3. So BC equal to 8 by root 3. Now we rationalize by multiplying by root 3 the both numerator and denominator, and we get 80 root 3 by 3, that is 46.2, because root 3 we are putting 1.732. Now we are taking the full triangle AC by 80. AC, the total height by 80 is tan 60. So we are getting 80 root 3, the value of AC, the full height. The full height value of AC as 80 into root 3. Root 3 equal to 1.732. So we are getting this value. So subtract this value from this value to get the extra height that was built. The total height minus the height which was built when the tower was incomplete, and you get 92.4 meters, the extra height that was built during the period Monday to Friday. Now we have got Sample problem 3. Flying at 1 kilometer fixed altitude, an aeroplane finds the angle of elevation of the same point on the ground changes from 60 to 30 in 10 seconds. So this is the aeroplane. Now, the point of observation is fixed. It doesn't change. The aeroplane was at A. After 10 seconds, it is going to B. At first, the angle of depression was 60, and then later, the angle of depression was 30. But then we know this is the alternate angle, so this will be 60 and this will be 30. But now, we don't have any right angle triangles. So we draw the altitude, which is 1 kilometer altitude or 1000 meters. Now we get the right angle triangles when we drop the two perpendiculars, and we know that the height is 1000 meters fixed. Now let us see. 1000, that is 1 kilometer, we are taking as 1000 in meters. 1000 by PR, we are taking the full triangle, so PR. We are taking this triangle, this triangle, this triangle. So 1000 height by PR. We are getting tan 30, that's 1 by root 3. So PR value we are getting. And now we are taking the smaller triangle, this triangle only. We are taking this triangle only. So we get only PQ. The height remains 1000. So 1000 by PQ is root 3 tan 60. So we are getting this value for PQ. Now when we subtract and we put root 3 equal to 1.732, we get 1154 meters. That is the distance traveled in 10 seconds. So the distance traveled in 1 hour or 3600 seconds would be, this is in meters. Then we mark off 3 decimal places to get kilometers. That is 415.692 or approximately 415.7 kilometers. So this would be kilometers. We have already changed meters to kilometers. 415.7 kilometers per hour. Sample problem number 5. A tower is surmounted by a flagstaff. The height of the flagstaff is h. From a point to the ground, the angles of elevation of the bottom and the top of the flagstaff are alpha and beta. Show that this is the height of the tower. This is the height of the tower x. You have to show that x is equal to this expression. This is the extra height of the flagstaff. So the total height would be h plus x. And this is alpha and this is beta. Alpha when you are looking at the bottom of the flagstaff, and beta when you are looking at the top. So take this triangle, only this triangle we are taking, that is this x by d. This is the distance d. X by d equal to tan alpha. Now we are taking the full height, h plus x upon d is tan beta. Now we do not need d. D is not required, so we divide the equations 1 and 2 in order to eliminate d. When you divide, that d will cancel and we will get this one. And then on simplifying, you get the value of x as this much, which is what we had to show. So h plus x upon d is tan beta and x by d is tan alpha. Divide the equations in order to eliminate d. We don't need d. And then you are getting this one. And on simplifying, you are getting the value of x as h tan alpha upon tan beta minus tan alpha. Sorry, there will be no x here. There will be no x here. X we have already taken. It would be tan beta minus tan alpha. This is what you have to show there. X also will not be here. We have already taken the common x. So it would be h tan alpha divided by tan beta minus tan alpha. So this is what we had to show, and we have proved that. So if you master these 5 problems on height and distance, the concept, the way in which we have approached, the way in which we have drawn the diagrams, and the way in which we have solved, once you understand these 5, you will never get stuck up when you encounter any problem on height and distance. That was Easy Elite English Educational Trust. If you need videos on any specific topic, you can WhatsApp us or email us, because all our charges are completely free of charge. Till then, thank you and Goodbye.